This is the second lesson of counting rules, and in this lesson we will discuss permutation. In first lesson we have learned the fundamental counting rules, why we use fundamental counting rules, what is the formula. In this lesson we are going to learn about permutation, and we will do some problems with the help of our formula in order to understand the permutation. So in order to find out all the possible outcomes, here I am going to explain one more time that why we use these rules. In order to find out all the possible outcomes for the sequence of an event. Suppose if you have two events, you have three events, and you want to find out all the possible outcomes, then you have to use these three rules. The first one is the fundamental, second one is permutation and combination. So we are here. Permutation rule. Permutation is an arrangement of n objects. See, n means any number of objects. Suppose you have 2 or 3 or 4 or whatever. So if you have 5 objects, how you can arrange these 5 objects in an arrangement or in a specific order, which is called the permutation. Permutation uses the factorial notation. So what is the factorial notation? This one, and you will find it on the top of 1 on your keyboard. This is factorial. If I will say suppose 5 factorial, then how you will write down 5 factorial is equal to 5 multiply by 4 multiply by 3 multiply by 2 then multiply by 1. This is called the 5 factorial. Similarly, if you want to write down 6 factorial, write down 6, and then from 1 to 6 you can write down from here 1 2 write 3 4 5 and 6, and this dot represents multiplication. Sometimes you will find out dot in your book, so it means multiplication. You have to multiply. So in permutation uses factorial notation. The factorial notation uses exclamation mark, this one. Factorial is the product of all the positive numbers from 1 to a number, right? Product means multiplication. So 4 factorial is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. Similarly, 8 factorial is equal to 8 multiplied by 7, 6, and then multiply 5, 4, 3, 2, 1. Here I have set a question in order to understand the permutation. A home buyer has a choice of 6 houses to buy. He decides to rank each house according to certain criteria such as price of the house and location. How many different ways can he rank the 6 houses? Right? He has 6 houses, so he wants to make a ranking of these 6 houses according to the price and location. So 6 houses, right? It means 6 factorial, because it says that in permutation you have to use the factorial. So 6 factorial means 6 multiplied by 5, 4, 3, 2, 1. So there are 720 different ways of ranking these 6 houses. This is in this example he is considering all 6 houses, but in the example B, this is the second part. Suppose he wishes to rank only top 3 of the houses. So it does not mean that you will write down 3 factorial, then 3 multiplied by 2 multiplied by 1. Then in this way you will get only 6 different ways, which is wrong. Out of these 6, he wishes to rank only the top 3 of the houses. So this in 6 factorial, these 3 are considering the top 3. 6 multiplied by 5 multiplied by 4. So when you will multiply this, you will get 120 different ways. Right? One more question. There are 2 different rules of permutation. This is rule number 1. Find the number of ways. This is rule number 1. You have to find out the number of ways that R objects can be selected from n objects. Suppose you have 10 objects or 15 objects or 8 objects, right? Just like we had 6 houses. If you want to pick 3, if you want to pick 2, so how you will find out? So the first rule of permutation is find the number of ways. that R objects can be selected from N objects, and this is the formula. It says NPR. N is the total number of the objects, N is the whatever you want, 3 or 2 or 5 or what. So the formula is N factorial divided by N minus R, total number minus the required number, and then factorial. So we will see the same example, this example, with the help of formula. In the first part says 6 houses, and he wants to find the ranking of 6 houses. He is considering all 6 houses. So n means 6 factorial, and then n is 6, and he wants 6, right? Because in the first example he is considering all 6 minus 6 factorial. So this 6 means 6 multiplied by 5 multiplied by 4, 3, 2, 1, right? And this 6 minus 6 means 0, which will be 0 factorial. And keep in mind that 0 factorial always equal to 1. So in the denominator we have 0 factorial, which is 1. You just have to multiply the numerator, because factorial means multiplication. You have to multiply 6, 5, 4, 3, 2. You will get 720 different ways. Same answer whatever we did here, 6 factorial. Here we have used the formula, but previous we just multiply 6 factorial. Now we will discuss the B part with the help of a formula, that he wishes top 3 houses, right here, top 3. So in the numerator is n factorial, because n, and then n minus r is the 3 houses, and factorial. So 6 factorial is total 6, 5, 3, 2, 1. In denominator we have 6 minus 3, 3 factorial, which will be equal to 3 multiplied by 2 multiplied by 1. So I have mentioned same thing here, 3 factorial, 3 to 1. So this 3 to 1 in the numerator and denominator will cancel out. If we will multiply 6, 5 times 30, 34 times 120, 120 different ways how he will select the top 3 houses. Same thing we have calculated here without the formula. This is the rule number 1. You have to find out number of ways that R objects can be selected from N objects. And then rule 2 of permutation is the number of permutations of N objects when R1 objects are identical, R2 objects are identical, and so on. Now what does it mean? I will show you here with the help of example. How many permutations of the letters can be made from the word accounting? Right, so you have to find out how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters, n factorial. So instead of n we will write down 10 factorial. In the denominator you have to see how many times a is there. There is only one time, c 2 time, o 1 time, and n 2 time. All are one time. So I will write down r1 factorial, r2 individually. This is r1, r2, r3, r4, r, each letter, right? If it is 2 times c, so we will say this is r2. We will not say r2, r3. These together is r2, and 2 times, so it is together r4 or r5, whatever. So 1 and 2 factorial, because 2 is 2 time, here n is 2 time, all are 1. So 2 factorial means 2 multiplied by 1, which is equal to 1. So 2 times 4. In the denominator we have 4. In the numerator we have 10 factorial. So multiply 10 multiplied by 9, 8, 7, 6. All this divided by 4. We will get 907, 200 permutation that can be made from the word accounting. Right, so I will give you a practice problem. So just take the example of a statistics, because we are learning statistics. You have to find out total number of permutations. How many permutations of the letters can be made from the word statistics? See here, you have 3 times s, 1, 2, 3. So for s is r1, because it is on, so you have to write down in the denominator 3 factorial. Similarly, t is 3 times, so you have to write down 3 factorial. And when you will multiply it, 3 multiply by 2 multiply by 1. Here 3 multiply by 2 multiply by 1, all is 1 time, so you, and I is 2 time. Instead of I, you have to write down 2 factorial, and a and c, these are 1 time 1 factorial. So this is your practice 1. You can write down the answer in comment section, and I will try my best to help you. If still you have any question, you can write down. Please do not forget to subscribe to my channel Saima Academy, and thanks for watching.